Hello students. So in the previous class we have discussed about refraction of light. Based on that, today we are going to continue a further topic. So the topic is refraction through a rectangular glass slab. So rectangular glass slab means here we are considering two mediums, isn't it? This is a air medium and this is a glass medium. That is air medium means you can take this one as rarer medium, and this glass prism or glass slab means it is a denser medium. Now what happens to the refraction in the case of rectangular glass slab? That means here we have to consider ray of light or the light traveling from rarer medium to denser medium. So first let us take a light ray which is passing incident ray, that is passing from rarer medium to denser medium. You know this is a point of incidence. So let me draw a normal line to this. That is, I am going to denote it as N and as well as N dash. And this I am going to denote as P. So before that, this rectangular glass slab I am going to denote as ABCD. ABCD is a rectangular glass slab where AB is parallel to the CD here. Now P and Q is the incident ray. PQ is the incident ray and this is the angle between them. So now you know when light travels from rarer medium to denser medium, the light ray bends towards the normal. So that means towards the normal light has been bended. So let me continue this bending. So that means it comes to this position. Now you can see here, this is rarer medium, this is denser medium, and now see here, the light ray has been from denser medium, it has traveled. Now when it comes to this point of incidence, now it is transferring from denser medium to the rarer medium, isn't it? Now light has been traveling from the denser to rarer medium. For this also I am going to denote the normal line. I am going to take it as M and as well as M dash. Now what happens when light ray has been traveling from denser medium to rarer medium? You know when light ray traveling from denser medium to rarer medium, the light ray bends away from the normal, isn't it? This is away from the normal, the light ray has bent. Arrow mark should be there. This is the incident ray and it passes through here, and this is the this one. Okay. So now what are the parameters we are going to denote it? Let us do it. So here, what is the incident ray? I am going to take it as I1. And this is the refracted ray. I am going to take it as R1. Okay, incident ray I1. I will write it as I1 is the angle of incidence. And R1 is the angle of refraction. And now after that you can see this. This is one angle which is forming. I am going to take it as I2. This I2 is also an angle of incidence. That is, it is incidenting on from this denser medium to rarer medium. This is I am going to denote as R2. This R2 is angle of emergence. Okay, this is not angle of refraction we are going to say. So we are going to say that angle of emergence. That means light has been emerging from denser medium to rarer medium. You are going to take that as angle of emergence here. So now, we based on the concept what we have discussed, that is rarer medium to denser medium to rarer medium. Based on understanding that, we have got these points. Now, for example, if there is no bending of light rays has taken. So before that, if this is the PQ is there means, then this I am going to denote as R. This is the point of incidence and this is S. That is the emergent rays I have considered. This is called RS is called emergent ray. PQ, I'll write it. PQ is called the incident ray. PQ is incident ray and QR is denoted as the refracted ray and RS is denoted as the emergent ray. Okay, so now here in this case, for instance, if there is no bending has taken place, then if there is no bending means where the light ray will be, maybe the light ray imaginary lines, I'll draw this. So the light ray will be maybe here. That I'm going to write it as S dash. S dash, this is the S point, no? S dash maybe if there is no bending takes place. For example, if there is no glass slab is there means, then the bending, maybe the light ray may be traveling in a straight line without any bending it. You can see there is a shift has been taken place from S dash to S. There is a shift has taken. That shift we are going to take it as lateral shift. The shift without bending and the shift with bending, we are going to denote it as the lateral shift. Okay, this is the concept about how the refraction takes place in a rectangular glass slab. Here the very important thing is you have to know which is the rarer medium, which is the denser medium, and how the light ray travels from rarer medium to denser medium. So the next concept is laws of refraction. Similar to the laws of reflection, what we have discussed previously about in the reflection concept, same thing, same as it is like reflection, here laws of refractions are also there. There are two laws of refraction are there. Under that first laws of refraction says that, so here you know this is a medium, we have considered rarer medium to denser medium. Now this is the incident ray and this is the normal ray. So this is the refracted ray. This one I'll consider as I and this one I'm going to consider as R. Okay, this is PQ R, we are going to denote it. So what does first law of refraction says means the incident ray, that is what is the incident ray here, PQ. The incident ray, the refracted ray, this is QR, the incident ray, the refracted ray, and the normal here, N and N dash, it is normal, and the normal at the point of incidence, this is the point of incidence, I will take it as A here. Okay, so the incident ray, the refracted ray, and the normal at the point of incidence this is common in the case of laws of reflection, isn't it? Same thing we are going to say incident ray. Instead of refracted ray, you have said that it is a reflected ray. The incident ray, refracted ray, and the normal at the point of incidence between, here this one term we have to include, between two transparent medium. Okay, here we have considered two transparent medium. Between two transparent medium, all lie on the same plane. All lie on the same plane. Okay, so the one thing we have to include between the two transparent medium, that we have to include here, or else everything what we have discussed in the laws of reflection, same as it is first law of reflection, first law of refraction is also. Now what about the second one? Second law is also called it as the Snell's law. Okay, by the scientist called Snell, this has been got this law, that is Snell's law. What is this Snell's law says means the ratio of sine of angle of incidence to the sine of angle of refraction is a constant. Okay, I'll repeat it. Ratio of sine of angle of incidence, angle of incidence is I, Sine of angle of incidence is nothing but this is the sine. This is the in trigonometry you will get this sine, cos, tan and all. So this is for this study you have to just know that it is sine of angle of incidence divided by ratio of sine of angle of incidence divided by sine of angle of refraction is a constant. This constant we are going to denote it by the n here. This constant is also called it as n is also called refractive index. Okay, this n is also called as refractive index. In solving some of the problems, in some of the questions, this is required. That is, constant or refractive index is equals to sine of angle of incidence divided by ratio of sine of angle of incidence divided by sine of angle of refraction. So refractive index means what? Means that is n we are going to denote. So it is nothing but speed of light in one medium divided by speed of light in another medium. I can write speed of light in medium 1 divided by speed of light in medium 2. That means this refractive index depends upon the speed of light. So what is this medium 1 and what is this medium 2 means? You know there are different mediums. So rarer medium is there, denser medium is there. So and very important thing here is where the speed of light is more. The speed of light is more in the case of vacuum, isn't it? There will be more speed of light will travel faster in the vacuum compared to air and faster in air compared to that water or the glass. This is the order of the speed of light. Okay, speed of light is more. That means light travels more speed in the case of vacuum than compared to air, and in air it is faster compared to that of water or the glass here. So for instance, if you have considered these two mediums, means vacuum will become rarer medium and air will become the denser medium. If you consider air and water or glass, means air will become rarer medium and water will become or the glass will become the denser medium here. Now for example, if you have considered a medium, will consider this is a medium, glass medium I have considered. Light has been incident on it. So this is the incident ray and this is the refracted ray. So this is medium 1 and this is the medium 2. Now I want to find the refractive index. How we are going to find the refractive index means here we are going to find the refractive index of medium 2 with respect to medium 1. Okay, that is n21. n21 is nothing but refractive index of medium 2 with respect to medium 1. Okay, that is n21 we are going to denote. So now n21 is equals to. So what is the formula? Speed of light. So for this formula, speed of light in medium 1 divided by speed of light in medium 2. Okay, this is refractive index of medium 2 with respect to medium 1. Now refractive index of medium 1 with respect to medium 2, we are going to take it as speed of light, reverse, speed of light in medium 2 divided by speed of light in medium 1. Okay, what is speed of light? We are going to denote as V. V1 divided by V2, that is N21 is equals to V1 by V2. N12 is equals to V2 divided by V1. Okay, so that means what we can conclude here, refractive index directly depends upon the speed of light, whether the medium is vacuum medium or it is air medium or it is the water or the glass medium. Okay, I hope everyone have understood this. If any doubts is there, we will discuss in a live session. Thank you.